What's up, guys? Welcome back to the channel. My name is John, and this is John Paul Investing. So today I wanted to talk about an interview with the CEO of Nano, Yoav Stern, that I discovered on Soundcloud. The interview is conducted by Leslie Langnaw, and she runs a 3D printing blog where she covers a variety of different 3D printing companies. So if you have any interest in other 3D printing companies like Stratasys or Nano, just to name a couple, then I would highly recommend you go to makepartsfast.com or check out this other website. I'm not sure if it belongs to her, but it's called designworldonline.com. It's also another website revolved around 3D printing. But that's not what I want to talk about. What I want to talk about is the interview with CEO of Nano, Yoav Stern. The way this interview is conducted kind of gets us into the mind of Yoav Stern, and I thought it was very interesting. He has a friendly temperament, but he's very confident around the product, and some people thought it was a sign of arrogance. But if you listen to the interview and hear what he has to say, I believe he's just very confident where the product is and where it's going. And also, his strong temperament really just means he's not really easily manipulated. And I think this is really going to be a good thing, because we don't want anyone, stirring Nano Dimension with a few bucks. Someone trying to run in and acquire Nano Dimension before, they've even had any real breakthroughs. It would be a shame to, put that all down the drain. And it also shows us how aware he is of the challenges and struggles into making the additive manufacturing of electronics to work. So I think Yoav Stern does have a vision for this company. I think it's just a really good interview, and it only has around 600 views on SoundCloud as of this recording. If you guys want to listen to that interview, I'm going to put a link in the description. Now, I did have to listen to it several times to really, dissect the information that he was giving us. If you're going to listen to it, you come back to this video and use it as a way to dissect what is being said in that interview.
First, why 3D print electronics? What are the benefits?
Well, we have to start by defining what is 3D print electronic, because there's misconceptions about it. We're using machines or printers that use technology for 3D printing by injection of inks, for that matter. Mm-hmm. But 3D printed electronics are divided between that and added manufactured electronic, AME. The difference is 3D printing electronic is when you take injection ink, let's say it's silver, and you inject it and you create a circuit on any three-dimensional or non-three-dimensional entity. For instance, when you print on the back of your window in the car, there's electric circuit that makes it warmer in the winter, if you remember. Mm-hmm. So that's 3D printed electronic, because you print a layer of silver, for that matter, that is creating this on the glass. But AME, added manufactured electronic, is really printing electronics in three-dimensional, which means taking the material, be it printed conductive and dielectric, and printing electronic circuit like PCBs that are in three-dimensional by adding more material and more conductive or more additive material as we go up in the 3D. Now, back to your question, why using it? So I'll divide it between 3D and AME. 3D you use because it's easier and faster and more efficient to print on the back of the window on the glass with a printer than doing it by analog printing, which means you have to somehow create the printed circuit on a different screen, let's say, and then you have to type or rather glue the screen on the back of the window and then peel it off. Very complicated, takes longer and not efficient. Okay. So that's relatively straightforward. On an AME, why use AME? Because additive manufactured electronics can make parts, printed circuit boards that are very sophisticated, that cannot be made otherwise in a traditional PCB industry. So it's much more innovative and breakthrough as much as technology.
Okay. So Leslie Langnaw's first question is, why use 3D printed electronics and what are the benefits? So Yoav Stern tells us that first we have to understand the difference between 3D printing of electronics and additive manufacturing of electronics. The main difference is that with 3D printing of electronics, it is only a topical layer on any surface that you choose. So in his example, he used a car window for some kind of printed layer of electronics that essentially would be able to heat the surface and keep snow and ice off of the window. Or in other cases, it could be used in a more complex surface, but essentially it is just a single topical layer on any surface. But with the additive manufacturing of electronics, it is essentially going from the ground up in full 3 dimensions, and you are able to integrate certain electronic components within the 3D printed circuit board or whatever smart device you're trying to make. And this is something that's really not able to be done right now with the traditional process. And the benefits is that you can create very sophisticated printed circuit boards or electronics that would not otherwise be manufacturable if you were to use traditional methods.
Okay, but now are there some maybe lesser known challenges to 3D printing electronics? And if so, what are some of those that a designer needs to keep in mind?
Okay, the main challenges, and I will focus on the challenges of the AME rather than 3D. The 3D printing the challenges are mostly how to print on entities that are complicated in size or in three-dimensional structure. That's for the 3D printing electronics. It's relatively simple. It's more complicated, let's say, than a flat window of a car, et cetera, et cetera. It's more of the shape of what you print on because you only print one layer.
Mm-hmm.
Once you go to AME, there's a lot of other challenges because the AME changes the capabilities of your own user product. Its weight, it's much lighter, its size, it's very small. So there are issues. Now we're going into the challenges directly to your question. You print 2 materials at once because there's dielectric and the conductive. How do they interface together while you print them? What are the characteristics of this material? The conductive being some kind of a special silver and the dielectric being a polymer. How are they compared to the traditional 40 years old analog industry of PCBs, which are using FR4 and all kind of materials that are different? How is the repeatability of the machines? You print a whole product, like completely convert digital file into a full product from nothing to a full working product. Is it repeatable? Are all the product the same? What is the speed of doing this? Are the machine fast enough so they can replace manufacturing? Is it real 3D? Can it really print in 3-dimensional, which means there's layers and layers and additional layers. It's not one layer of circuit. It's dozens of layers, if not hundreds of layers, with vias, with holes. You don't need to drill holes. So can you do that? That's a challenge. And of course, in the end, what is the environmental condition that the end material can work in? High temperature, low temperature. It's a total digital industry where you start from a file you design and you have an end product and you have to go through these challenges I just described.
Leslie Langnon's second question is, what are the lesser known challenges of additive manufacturing of electronics? Yoav Stern then goes back to, again, the comparison to traditional 3D printing, or at least what we believe 3D printing is. The challenges of that 3D printing process is basically the complexity of the material that you want to print the topical layer on. However, with the additive manufacturing of electronics, the challenges are much more complex. First, we have to print the conductive and the dielectric material at once, and you have to make sure that these 2 materials that you're printing don't interfere with each other because they have very different properties. The whole concept of going from a fully digital file into a physical product is also a very new concept, and they have to study the repeatability of this process. Can they make multiple prints that are identical to each other and, be reliable? Can it connect the 2 materials reliably together is also a question. And once you have the end product, you have to worry about the resistance to harsh environments. They want to be able to make more materials that last longer in more harsh environments because then they'll have more use cases for their products.
Okay. Now, I've seen Nano Dimension at many of the additive manufacturing shows over the past few years. So how has 3D printing electronics changed?
Well, it's easy. It's easy to speak about how do AME and 3D manufacturing change over the last 2 months because the world have changed.
Yes, that's true.
So we can speak about that. I mean, who remembers the last 2 years after the last 2 months? In the last 2 years, I'll speak both on the 2 years and the 2 months, okay?
Okay.
So the last 2 years, there's an advancement and people start to understand the difference between just 3D printed electronics and AME, additively manufactured electronics. They start to understand that in 3D printed electronics, they can have more and more applications, of printing a circuit, one layer on different entities, which will replace traditional ways of having that printed circuits on whatever entities. But there's not huge, I would say, curve or inflection points. On the AME, things changed over the last 2 years. The first AME machines, real AME machines, came out, which happened to be Nano dimension. So I'm tooting my own horn. So I'll try not to do that. Sorry about that. But that came just a year and a half ago. And to be frank, our earlier machines were not 24/7 working, so we had to fix them and we upgraded them. The new machines only came in the end of 2019, if you can believe it. And that is a very, very big difference, because suddenly the people, and including the big guys which are talking to us, realize that you can create something from nothing. Now, it's not something from nothing. It's some finished end user electronic product from a digital file. That's a major thing that happened in the last 2 years. It didn't happen before in the AME market, and now there's more and more people looking at that and trying to work out two materials into one product, and to be a totally independent fab, which means a standalone digital to end user product machine. And those machines are in a stage of advanced development. Proof of concept is already there. The machines are working, but they're not yet into full production of PCB, of AME. They are into producing prototypes. And that's what the industry is seeing. Everybody is trying to push it toward production.
Leslie Langnau's third question was, what has changed over the last few years in 3D printing? This is where Yoav Stern really starts to mention the big guys, or the guys who are, starting to take notice of Nano Dimension's technology. Again, he brings up the difference between, 2D printing on just topical layers and with additive manufacturing, where they're really making 3D printed electronics from the ground up. With the 2D printing, it's a very simple concept, and they can roll out a high quantity of 2D printed electronics, but there's really no inflection point. There's not really much you can do with it. Just a couple years ago, they had the Dragonfly Pro, which was able to print 3D printed circuit boards, but it required a lot of human intervention. But as time went on, they were able to progress into the Dragonfly LDM, or the lights out digital manufacturing model, which was able to run 24/7 without any human intervention. Another thing that's changed in terms of 3D printing is the fact that with their technology, they are going from a completely digital file, something that doesn't exist, into creating a physical product that you can touch, feel, and use, and apply it in whatever process you're trying to achieve. There's no middleman process when printing your own circuit board. It's a fully standalone process with your own fab in-house. Over the last few years, they've also secured their proof of concept, so they already proved the technology works.
And that connects me to the last 2 months. There's a huge trend, and I don't know if you followed it up. It's everywhere in the media, in the business media, especially in the electronic business media, where the big guys have realized that they became addicted to the Far East manufacturing of printed circuit boards in general, and actually specific, and in general to electronics. And they realized that and they got addicted to this low cost, very high quantities, which China and Taiwan supplied. And they are realizing now that after a crisis, actually 2 crises. One started with the American administration forcing the trade war with China and the tariffs, and the second just followed that into the Corona days. And suddenly they realized all the money they made in manufacturing electronics in the Far East over the last few years, they may be losing now. Moreover, they are so dependent, they have no manufacturing on the ground, on the continents, and they have no buffer zones. So there's a huge trend in the 3D and AME of people in the industry realizing that AME is a perfect solution to manufacture PCBs or special electronics on the ground, on the continents, because it's a clean industry. It's not analog, it's digital. There's very little waste. it's ecologically friendly, and it may create for them the buffer manufacturing on the ground between continuing to manufacture in the Far East, maybe in very high quantities, but in case there's issues, they can always have close to home, design in-house, manufacture in-house. That's a key thing. You don't send designs to the Far East. You design in-house, you prototype, you manufacture, and all it's a digital industry. So that one trend is accelerated over the last 2 months as a result of the corona.
He also mentions the fact that a lot of people relying on the East to create their circuit boards are starting to realize that it's not a bad solution to have your own in-house way of developing boards, or any other smart device for that matter. Of course, you can still have the other high output methods that they use in the East, but at least now you have some kind of in-house solution where you can protect your intellectual property and still have some kind of production capabilities. It's a perfect solution for the industry because it keeps it clean, it leaves little waste, making it eco-friendly, and it's a completely digital process, so it removes a lot of steps that would otherwise require materials and other things that you really don't need to do.
So what I'm hearing is that there's a huge potential for reshoring electronics back into other countries, doing it closer to home, wherever
Yes.
businesses may
Yes,
be.
exactly. And I want to tell you something, Leslie. The defense and more than defense, the government-related industries, call it defense, homeland security, and lots of other industries that are rightly so more nervous about cyber theft, realize earlier than the corona that it's very difficult for them to send designs not only outside the country, sometimes even inside the country they wouldn't send it to certain civil organizations because they need to keep it either governmental or defense. Here they have a solution that they don't have to send design. If they have machines at home, think about machines that are in a warehouse and there's 20, 30 machines. They do the design, they immediately convert the file into a prototype, a proof of concept. It works great. If not, they fix it, they do another proof of concept, and then if it works, they still take the end design and manufacture it in-house without sending anything abroad. That's a major additional advantage than just being able to manufacture on the ground, is the ability to keep the IP on the ground.
Right.
Leslie Langnau asks if there's a huge potential for reshoring manufacturing of electronics closer to home. Yoav Stern covers that the defense industry and pretty much any industry that's vulnerable to cyber theft would all be able to benefit from the in-house advantages of their Dragonfly printers. So Leslie asks how close we are to seeing higher production.
So now, how close would you say we are to shifting over into more of a higher production capability with 3D printed electronics?
I would say that again, going back to the earlier definition that we defined at the beginning of the call, if you're speaking about 3D printing just in two-dimensional, it's funny to say 3D printing at 2 dimensions, right?
Mm-hmm.
But 3D printing technology used to print, I'm saying it the long way, used to print circuits in really 2-dimensional or shapes of 2-dimensional. It's like the globe. We live on the globe, which is really 3-dimensional. Our Earth is 3-dimensional, but we are walking around in 2 dimensions, you and me.
Yep.
The ground is 2 dimensions for us, even though it's 3 dimensions. So it's the same with printed electronics. So those industries that are printed something on a surface are already in production, in early production, and they're working. The AME are not really in production. The technologies that manufacture real 3 dimensions circuits with layers and layers, with manufacturing components inside the PCB, which means you don't have to add components. You can print the components, the capacitors, the converters, the coils. This industry is in a stage of prototyping a proof of concept and is moving into early production, I believe, in the next 12 to 18 months maximum, maybe a bit less than 12 with a little bit of luck. That's where we are. And the Holy Grail is getting into early production. We already post the proof of concept, it works, customers are using it, and the early production is coming. The minute you get into early production, that's the inflection point, because then you start to really evolve into machines becoming populating production floors, which is beautiful.
And Yoav Stern does point to prototyping of early concepts as their end goal for now. And to him, the holy grail that we're going to see, at least in the medium term, is going to be whenever they start producing more machines and getting them out there, which we'll see between the next 6 to 12 months. Remember, this was recorded 6 months ago.
That should be a very interesting development too, as far as designs for the design engineer. Speaking of which, for an engineer who's looking into adding electronics into something that they're designing, 3D printed electronics, what are some of the key design considerations they need to be aware of?
You hit the nail on the head. There's the reason the AME, additively manufactured electronics, is such a comprehensive solution. The ability of the technology has to be integrated into the software that is being used for design. Because when you have a software for design, be it Mentor Graphics or be it SolidWorks, the CAD/CAM electronics, CAE, computer-aided electronics, are used the traditional design rules, and they're not familiar with the new capabilities of this technology. So if you are a manufacturer of AME machine like we are, you have to also develop the software. Let's call it like a design rule library that will be attached to the traditional CAD/CAM software. So people, engineers who are designing, will be able to include, for instance, the option to insert into the design a 50 layers capacitor, which the machine can produce. But if it doesn't have it in its software, it's not going to be able to integrate it into the design. Or a certain coil that you don't need to add a different coil from a manufacturer of coils or converter with coils. You can print your own coil. So what we do, for instance, and hopefully others, is we have a software package that integrates into the industry design softwares that is just like a library, so be able to use the design rules and leverage the advantage of the manufacturing capability of the machines.
Interesting.
So Yoav Stern actually gets very excited with this question. So Leslie asks for an engineer, what are the key design considerations they need to be aware of when using their machines? He says that she hit the nail on the head and that he was very flattered with this question basically. He says that the additive manufacturing of electronics is a very complex solution and it really needs to start at the software level where the engineer is going to be working. So Nano Dimension uses a software that integrates with already existing softwares like SolidWorks. It's proprietary to Nano Dimension, and it's able to expand the capabilities of SolidWorks. So what they're saying is if they can improve this software, then the end results will be better as time goes on. So using SolidWorks, they're able to leverage their own technology.
Are there any material considerations that are important?
Yeah, I would say even I'll take it one step further. The material in AME, the material and the process is the secret sauce. Everything is around the materials. You take polymer, which melts, at 100 something degrees Celsius, and you take silver, who melts at 900 and something degrees Celsius, and you inject them together, and they have to live together as injected, coming out of the machine, molded together and working. It's a real challenge. It's not a simple silver, and it's not a simple polymer. Once you change the silver a little bit, it's not working with the polymer, so you have to change the polymer. Once you change both of them, you have to change the process. You have to consider temperatures of the process as well as what temperatures the end product is going to work at, and in those temperatures, the product has to maintain its characteristic and not changing them. You have to consider what happens over time to polymers and silver when it's exposed to sun, ultraviolet, heat, cold. Does it lose its not capabilities, its characteristics? Does it change its characteristics? How long does it keep them? That is different for industries in defense. Their needs are different than industries that are commercial.
Mm-hmm.
More than that, how strong is the product? Can it break under G forces? When will it break? How is it comparing to the traditional PCBs or electronics? So everything is around the material, and the minute you change material in order to fit the spec of the end product or the vertical industries you're selling, then you have to change the process and you have to change the other material because they're all relating to each other. So once you ask this question, you hit almost the core breakthroughs in additive manufactured electronics in three-dimensional, which is the chemicals and the physics of the material and the algorithms that can control such a delicate process in real time.
So Leslie asks Yoav Stern, are there any material considerations that are important? And he said that additive manufacturing of electronics is the secret sauce to Nano Dimension's success. Everything revolves around the materials. You have the dielectric polymer at 100 degrees Celsius and the silver conductive material at 900 degrees Celsius, and you have to inject them together, they have to mold together, and they have to work together in harmony in extreme conditions coming out of the machine and work without fail. Different materials interact differently with each other, so new combinations will require chemical changes in the inks to accommodate those changes. Now, besides that, depending on the material, they have to ask themselves, well, how strong are these materials? Can it break under G-forces like jets, rockets, or any high-stress environments? It also has to fit the spec of the end product for the industry that it's selling to. So what might work for, let's say, commercial real estate might not work for something in the military space. The core breakthroughs will be the chemicals and physical capabilities of the new materials that they're developing. Along with this is the complexity of the algorithms in the machines and how they dispense the products.
Now, is there anything I haven't asked that you want to address?
Well, you didn't tell me how many machines you want to buy.
Me personally, how much do they cost?
Well, for you, we have a special price, Leslie.
Okay. That sounds good. It sounds like there's going to be a lot of interesting developments coming up even in the next few months for 3D printing electronics.
Yeah, we are very excited. Actually, I'll tell you, we have customers. The technology is so new. We had a user conference, the first one few days ago. We found out, and we have users and customers from all over Europe. It was in Europe, in Germany, in Europe. It was in Zoom video, but it was in Europe. And for 4 hours, we had customers working with our machines, Leslie, if you can believe it, that develop products that we didn't realize the machines can do.
Wow.
Which means we said, okay, just a minute. We didn't know this can do it. Let us take from you, how did you use the technology? We didn't know it can be used that way. It's really exciting. So, and the customers are excited because it's almost them participating in the development of the next generation of the machine by showing us what the present generation can do. So they kind of break the barriers, and then they tell us, this can do already this. Take it one step to the left or to the right, and it's another breakthrough. It's very, very exciting.
Quite an interesting form of collaboration there.
Exactly. And we're now formalize it with your customers. And it's funny how you really hit another nail on the head. We offered them to form a customers advisory board to our R&D and product team, and which will meet once in 2-3 months. And they were very excited, because all the customers don't feel they're competing with each other. They're all kind of working and sharing information because it's going to expand the industry. It's not going to overlap and push each other. It's going to open more horizons for all of them. So we're going to establish now and start to operate a customers advisory committee along the lines I just described.
So Leslie asks if there's anything that she might have missed that he wants to talk about. And he gave us some very good intelligence. So he said they had a virtual conference with a ton of customers that are based in Europe. They were in a Zoom call for over 4 hours. And what he revealed is that some of the customers were able to use the Dragonfly printers and develop products that even Nano Dimension did not think were possible. And with these breakthroughs that even Nano Dimension didn't know were possible, they're able to improve future machines to accommodate these breakthroughs. So what Nano Dimension did with this is that they made a customers advisory board that would communicate with Nano Dimension's research and development team. And in this case, the customers aren't working against each other, but working with each other to develop new breakthroughs in Nano Dimension's technology. So all of these customers are essentially pulling their ideas together to improve Nano Dimension's future printers. So with that being said, they're essentially going to expand the entire industry and open new horizons for new innovative products.
I have to say, as far as I'm aware, you are the most well-known company of someone who makes 3D printed systems for electronics. Are there others in the industry?
Yeah, there are more. There are a company like Optomaker in the United States that is doing what I described to you before, printing just one layer of silver electronics on any three-dimensional entity. There's competitors to Optomec in Europe, few of them. There's companies that develop all kind of inks for electronic industry, like KAO from Japan. But they only develop the inks, and mostly the conductive inks, not the electric. There's companies who develop machines, like in Germany, Notion, but they only buy machines. They don't have the inks. Sorry, they only build machines. They don't have the inks.
Okay.
And therefore the machines are mostly built on spec. So there are companies, and of course the big guys, the Samsungs and the Siemenses and the Lockheeds, are talking to us and about things they do. And the big guys are having this technology pushed forward in-house. So those are kind of few of the players.
Nano Dimension names Optomec a competitor printing single layers of 2D nanoconductive silver inks only. Other companies are developing certain materials, but they don't have the machine to dispense them. There's a German company called Notions that is only building the machine, but they don't have the inks. And they're built to certain specifications based on certain customer needs, so it's not a universal product. Yoav Stern also mentions that there is 3 big companies looking at them right now. We have Samsung, we have Siemens, and we have Lockheed Martin. We already know recently that J. Christopher Moran, the general manager and director of Lockheed Martin Ventures, joined the Nano Dimension board not too long ago. So this information checks out. And on top of that, we have Siemens and Samsung that we really haven't heard too much about, but I'm sure as time goes on, we'll start hearing more from these guys. And a final note that I wanted to mention was comparing Nano Dimension. This is probably a bad analogy, but comparing it to, like, let's say social media when it first came out. So with social media, you just simply have a platform with nothing on it. What adds value is the people and the ideas that you put on it. So we can compare that similar to Nano Dimension, where they're serving a product that essentially you can create whatever you want with it. And depending on what you create is whatever value comes out of it. So I think over time, we're going to start seeing more and more value created out of these machines. We just haven't quite gotten to the full possibilities of the machines. And the secret sauce, as Yoav Stern mentioned, is going to be what propels Nano Dimension forward into a new era of 3D printing and additive manufacturing of electronics. But anyways, guys, that is a majority of the interview. I'm going to leave a link to the SoundCloud interview so you can listen to it in its entirety without any interruptions. And I always welcome open discussion in the comments because this helps people who are new to the channel to understand Nano Dimension a little bit more. But anyways, guys, that is it for this video. Thank you guys so much for watching. If you liked what you were watching, go ahead and hit that like button. And while you're down there, go ahead and hit that big red subscribe button. And don't forget to hit the bell notification to get notified when I make videos just like this one. But anyways, guys, that is it for this video. Thank you for watching, and I will see you in the next video.